Hey everybody, and welcome back to another episode of Socialites Podcast with me, Gustav Hultgren, as your host. In today's episode, we sit down and talk to physician Igor Dotsenko. Igor is really one of Ukraine's young and bright minds. And as one of the 5 permanent members of the team, together with Serge Harosh, Igor will tell us how it felt when they won the Nobel Prize in Physics in 2012. Igor will also tell us how he ended up where he is today from his beginnings in Cherkasy, as well as trying to explain what he actually does in his work. Furthermore, Igor gives us a little bit of insight into what his feelings are for the difference in academic culture between Ukraine and the West. We hope that you enjoyed the show. We thank you very much for listening and staying with us. Please note that we have now a YouTube channel as well, so if you search for socialite.nu, you will find all of our shows there, as well as, of course, through our webpage or iTunes. So I'm sitting here together with Igor Dotsenko. Thank you for joining us. We will be talking a little bit about your work today, but I think you are a doctor in natural sciences from the Bonn University. I think that it's interesting to hear how you ended up where you are today. Sure. And obviously hopefully that you can maybe try to explain a little bit what it is that you do as well.
Of course, when we're talking about present, we should start about something that happened a long time ago. So when I was a student, when I was a pupil in school, so I was going to the Cherkasy Lyceum, so it's Physics and Mathematics Lyceum, Cherkasy, which I think is still one of the best schools in Ukraine. And then I was interested in mathematics and physics. And I was not so bad in these 2 sciences. And then we participated in lots of Olympiads, like Kangaroo in France. And just naturally, after finishing from the secondary school, I decided to try myself in physics. And I applied to the Kiev National University, to the physical department. I was accepted. I entered directly the optics division. And I spent 4 years making bachelor in laser and optoelectronic science. So it's just background for being optician, but not medician. And then it happened that I got married and with my wife, and we decided that it's a good time to continue the study outside Ukraine. And she got the PhD position in Aachen, in Germany.
So she's also a scientist?
Yeah, she's also a physicist.
Okay.
So we got married in the physical department, and also optician. And then I just found the program which was called Bonn International Master Program in Physics. So organized by the Bonn University in the Institute of Applied Physics. And then they just make a call for everyone who wanted to finish master degree in Germany after finishing their own bachelor degrees worldwide. So the course was designed for a couple of years, including the lectures in English basically, and also 1 year of the practical work in the lab. So it's really just making the real thesis, master thesis.
Do you think you would have ended up with this career choice even if you had not started the school in Cherkasy from the beginning? Or was this sort of a...
Definitely, I would not be where I am now. It's for sure, because before I entered into this lyceum, into this environment of physics and mathematics and chemistry, I was never thinking about natural sciences. I just was a boy which was interested in everything, but nothing was really systematized. But due to this school, so we were really concentrated. So first we were isolated from all problems because it was the beginning of 90s, lots of economical problems, but we were kind of isolated from all these problems. And we had very good teachers, really excellent teachers, and they helped us to motivate ourselves in doing a bit of science. And of course, we participated in all Olympiads, and it was really some kind of small environment where you know people from different schools, you have competition. Every year you start from the class competition, school, district, city, and then going to the national one, and then every year starts from the beginning, and you have different disciplines, maths, chemistry, and etc. And it was really a very nice environment. So it's like in sport, maybe you can compare. And then we just were interested in all this stuff, and when you get, so it was like avalanche effect. You start to learn something small, interesting, and then you get more interesting, going deeper and deeper and deeper, and then it gets larger and larger and larger. And then at the end, we were pretty successful on the Cherkasy level, even in the national level. So I participated in the national Olympiads in physics, and it was not so bad. So, and in my case, it's for sure that if I would not enter that special school, I would not study physics. So I'm really confident in that.
But this is a school that you do tests for in order to get in there before?
Frankly speaking, I don't really know how it's done now, because in that time, so the school just started. And actually one evening, my future teacher in maths, he just called my mother home, and he just asked if her son can come one day to this school, just write some test, just for entering the school. But nobody knew about that school. It was just really the first year of that establishment. And then many years later, my teacher explained me how they found us. They cheated. They were going through all schools in Cherkasy. They were asking for these big class books with notes for every student. And of course, it was not official. Because, of course, the principal of these schools, they knew that these people, it's like goodwill hunting. So they were hunting us. But they got legally all this information, and they knew that, okay, these pupil, this boy, girl, they are not so bad in some subjects. Okay, next stage is just to get some telephone number or address, and then just directly call and propose to make this entrance test and then enter this school. So it was really very first year, no information. It was back in 1992. So it was the year of this crisis, economical. So, and these teachers, they were really very motivated.
And who took the initiative for starting the school?
I don't know all these details, but initially this school was a part of the normal school. So we have one school, and then next to this school, there was just some classes from the 7th year up to 10th or 11th, just in the parallel to this main school. And then 1 year later, the administration decided of the basic school of Cherkasy. They decided to separate and to establish really new specialized school just for mathematics and physics. And they just took this part of the main school with all teachers, with all pupils, and they just moved all of them into the new building that we got in 93. And then from that time, we became really independent school. So it was new school, new principal, so everything was. So it was just the year of the birth. And actually this year is the 20th anniversary of my school. And I just came from Cherkasy, and so I was participating in some small events, in some small celebrations.
And then after this, you got a scholarship to go to Bonn, or you got accepted into Bonn University? Of course,
to go to Bonn, I got the scholarship from Germany. As I remember, I asked for the scholarship, but for them it was more or less automatically clear that if someone from the former Soviet Union wants to come to Germany, he will need money. Because and without money you cannot pay your insurance. So it was more or less automatically. And this program, it was established together with the German service, with the DAAD, so it's the German exchange system, which provides scholarship for German students studying outside of Germany and also for foreign students coming to Germany. And they just gave several scholarships to this program, and just the leader of this program decided how to distribute them. So in that time, they took about 10 people from Ukraine, Russia, India, China, South Africa, so really from everywhere. And we got this scholarship, which was really sufficient for us for two reasons. First of all, because it was not, even for Germany, it was enough. And second, we came from Ukraine, and in that time in Ukraine, we knew how to live on really several dollars per week. And for us, it was really good support. And then, of course, they provided directly the camp, the living rooms, the tickets for the local transportation, all discounts for the restaurant, and so on and so forth. So we felt ourselves really very comfortable. And I guess it was really a very important decision for me, because in Ukraine here I spent 4 years in the good university, but for me it was not enough. So all courses were a bit separated from one another. So in one good course you can learn how to solve some special equations in mathematics, and you get your excellent note and you can solve any type of equations and you are happy. But then no other lecturer in other courses uses this technique to support his own course. And you learn natural science is not like something global, uniform, but like some lake with small islands. Okay, this island called mathematical analysis, another one called spectroscopy, another one called, nuclear physics. But I couldn't get some kind of perspective and unification of all these big area. I don't know why. So this system was starting to collapse, and by inertia, lecturers, they continued their courses, but they started to diverge from one another, and at the end you don't have very nice harmony in the information that you get.
Do you think this has become better now?
Unfortunately, I don't know, because you should go to these courses, because even if you just see the list of courses that the university provides, you cannot conclude what quality will be, because the list that I provided in Bonn, for instance, it was really very huge, and they were surprised, and it was really good background according just to this bureaucracy, to this list of names of different lectures. But inside of each lecture it was a bit disconnected from everything else. And of course at that time I was still young, and I even could not conclude on it. I could not express this discomfort that I felt. It's like you feel some discomfort, something is strange, but you cannot summarize it. You don't know why, you're not experienced in making conclusions, but you feel that something is wrong. And then when I was still in my last year in Ukraine, I visited the lab of my wife, because we spent 1 year separated in Germany. And I was on the 4th year here, so I knew pretty well the basics of physics. And I saw the modern lab in Germany, and that was the final point. So once you see the modern lab, physical lab, with modern lasers, with modern electronics, computers, cryostats, there is no decision to make, So I was never really making decision. You just see it and I go here. And then I just finished the 4th year, I got the bachelor degree. So I applied in parallel to this Bonn program. So I was accepted, I was very happy. I was accepted to the 2-year courses. So I spent 1 year on listening to the lectures and 1 year on making master thesis.
And then you ended up getting your PhD from the Bonn University.
Oh, not so fast. So first since I was still from Laser Society here in Kiev, I have chosen the Laser Lab in Bonn to make my master thesis. Fortunately, it was the lab of very famous physicist, Dieter Meschede. Of course, for me, he was just one of the professors, but he's very famous and very nice experiments, and I entered directly into the high-level lab and high-level research. And it was so amazing research, so I spent this one year making my master thesis, so it's some kind of extended laboratory work that you do during one year. You have supervision from many other PhD students, from postdocs and of course from professors. And then you learn how to do different things, and you love more and more the subject, which we can call now quantum optics. It's basically about properties of different individual particles of light, particles of matter, and so on, and just really playing with them like we play football with a ball.
I wanted actually to come in a little bit on this. I think that probably not many of our listeners understand much about what it is that you actually do at work. What can you describe sort of an idiot's explanation to what it is?
There's no idiot explanations. So actually my master thesis and PhD thesis was on the same experiment, and everything was about trying to make experiments. So let's say really playing, like we play on billiard with balls, playing with individual single atoms, one by one, in vacuum. So you just pick up one atom, you pick up second atom, and you jungle them. Really, like you just shuffle them, you sort them. And to sort, you use light, you use laser light. Because you cannot touch atom with your fingers, which is already consists billions of other atoms. So you use special laser light to pick up single atoms. And then you use very sensitive cameras to make a photo of this, to see this atom. You can move this atom. And moving atom with atoms is a very famous technique, which is called optical tweezers. And it's famous because it's used not only in physics, but also in biology and in chemistry. So, for instance, they pick up with laser light end of your DNA, and they can just move your DNA inside of your cell using focused laser light. Of course, it should not be just laser light from laser pointer, it's something more delicate, but idea is the same. And then we use the same, but on the level of single atoms. And then you can take one atom, second, third atom. You can make some kind of abacus. You can make calculation with atoms. You have one on the left, two on the right, and then you shuffle them. So, of course, at this level, it's just toy. It's just to play. But, of course, to get to this play, there are many challenges because you need to control laser light. You need to stabilize laser. You need to know atomic physics. You need to know vacuum technology because everything is done in the vacuum. So you just play, and then of course it comes deeper into the more fundamental questions, not just playing with atoms, but questions of interaction between atoms and matter, or between two atoms, or making some kind of very funny situations which cannot be realized in our normal macroscopic life. We can do with atoms something that we cannot do with balls. And this is something that was raised by Schrödinger, by Einstein, Niels Bohr, back to 20s or 30s of the 20th century. People saw that quantum mechanics being very successful because it was predicting very nicely many results, it came to some paradoxes, to some ridiculous conclusions. So if you apply something which works very well with atoms to the microscopic world, then you get some nonsense. So for instance, with atoms, you can imagine that one atom can be at the same time in two different locations. So it's not just two different atoms or atom which is either left or right. It's really one atom which is at the same time left and right. But it's at the same time in two different locations, or in 3 locations, or in 5. So, and this is called superposition states. And Erwin Schrödinger, he thought that, okay, if we just apply this rule to the microscopic system, we might observe something ridiculous like a normal cat being at the same time dead and alive, which is also a kind of superposition. It's two different states, yeah. We cannot be at the same time, so it's not coma state. It's really either dead or alive. But in quantum mechanics, if the cat obeys these quantum laws, it should be at the same time, so we should be able to make it in this superposition state. And then Schrödinger said that this is the paradox, nonsense, and this doesn't work for sure because, come on, I don't see my cat being in this funny state. And we should be careful, and we should not apply directly quantum mechanics to the classical world. And this paradox is called Schrödinger cat. And yesterday I saw the doodle from Google with a very nice picture of the Schrödinger cat being dead and alive. So I saw it yesterday, maybe it's still there. It was 125-year anniversary of the Erwin Schrödinger and the doodle, so it was very funny. So okay, and with atoms we can make these states, and we can see this state, and then we can try to make these atoms more and more macroscopic. We can add other atoms, we can make the system more complicated and see whether this quantum state will survive this transition from the micro quantum to the macro classical.
So you mean that to take clusters of atoms and do the same thing?
Yeah, so as an example. So this is one example, so it's, yeah. Because of course the difference between one atom and the cat is that cat has billions of such atoms and one atom is just one atom. And of course when you go from the single particle to the ensemble of particles, situation changes and you go to the classical physics of Newton. And now, of course, the very fundamental questions is whether quantum mechanics is just some theory for micro world, Or maybe it's really theory for the micro world. We can apply it also for cars, people, and normal cats, but there is something else which prohibits these quantum states. And the question becomes more and more important. And now we come to if you want, to some kind of practical realization, so where it can be useful. So everyone is using GPS now to find your location and to synchronize different GPS clocks. So you use really some kind of clock. Your GPS gets the signal from the satellite. It counts how many cycles of wave came from that satellite. So he knows the distance from 3 satellites, and then he just calculates your position. But of course, to make this, you have to know exactly the time on all these different satellites. And nowadays, the best clocks are atomic clocks. So on each satellite, you have really atomic clock, which is extremely precise, which has precision or the fault 1 second per billion seconds. So every billionth second will be wrong, if you want. And then it allows you to find your position with the precision up to 0.5 meter or 1 meter. But now if you want to go to the better precision, you have to better synchronize this clock. So this clock should be better and better. So it should be not 1 second per billion seconds, but maybe 1 second per billion years. And then clock will be much better, and you can find your position more accurately. And of course, applications can be really very vast. And for this, in these atomic clocks, they use really superposition of atoms. It's difficult to explain technically how it works, but so we really use these quantum properties of atoms to make these clocks. And now, if we want to count better and better, then we use more and more atoms, and then our system grows larger and larger, and then we come to this problem that going to the classical world, quantum properties disappear. And then the precision of these kind of clocks became limited. And of course, the question to understand fundamentally what really limits this precision, and technically how we can push this limit further away to the classical side. And basically that was the Nobel Prize 2012. So for instance, our colleague Dave Weiland from the NIST in US, from the National Institute of Standard and Technology, at this moment he has the most precise atomic clocks in the world, which makes 1 second error if they would start counting from the Big Bang. So if you just launched this clock 13 billion years ago, so now they would be just 1 second behind or ahead. So it's the best clock. And for that, of course, he needs precise control of these individual particles, precise isolation, pushing this classical limit farther away.
But are these technologies applicable already today? Or is this still in
not
lab environment?
on this level of precision, not on this level second per billion years, but precision second per 10 to 12 seconds, you can apply it, and it's used like in GPS, in controlling different satellites, but also for another fundamental research. For instance, so now we have some experiments trying to detect gravitational waves. Maybe you have heard about these. So, for instance, we know that light is the electromagnetic wave. So we can detect it. We have radio, we have television, we have mobile phones. And we know that gravitation also propagates in space, and there should be also gravitational waves. And they try to detect these gravitational waves. And their detection is extremely difficult, because gravitational waves is something that comes here and it tries to stretch our space. But the idea is that it starts really to squeeze us or scratch or twist. But of course it's difficult to see, because if you are twisted and the room is twisted, you see no difference. And people are building extremely huge apparatus which can be up to 1 kilometer long, where you have 2 mirrors, you have light which comes back and forth between mirrors, and then we try to see how distance between these 2 mirrors will be shifted and changed due to the possible gravitational waves. And of course now sensitivity is enormous, and every small shaking of this mirror due to the thermal motion of atoms on this mirror, because they move, you cannot freeze them. Even this motion will introduce more effect than the effect of these possible gravitational waves. And of course you have to stabilize these mirrors, and then you make the mirror equal of the precise number of wavelengths of this laser light, such that even thermal motion can be partially compensated. And for that you use atomic clocks. And this is one of the possible applications. Of course, you still might think that this is more fundamental, the practical applications, but it really pushes technologies because as a result from this research, you have lots of byproducts, lots of additional solutions to smaller technical problems, which then find out their way in the industrial applications and in different devices that you might find in the office.
Is there a lot of industrial companies that are closely collaborating with your institutions?
Oh, yes. It's one of the most important conditions. You have to. Because we're pushing technology in the lab, you're making a kind of prototypes, and then when you have this prototype, you use this property, this precision to push another device, and you're pushing everything that you can push as far as you can. And of course, you cannot provide support for all these different devices, and many other groups might be also interested in these devices, in this technology, and then we have companies which try to commercialize this equipment, and then we come back to them, we buy their devices based on ideas of our previous generations, and we reuse them, but now as the desktop module that you don't need to open a line, and you just plug and play, and then you make another device or kind of device. And
so of course you invent it and then they sell it back to you.
Kind of, but of course it's more complicated. If you think about business, of course it's a bit more complicated. You have a system of patents and so on and so forth, especially in US, in Germany also. But in principle, it's the idea that you develop something that can be useful for you. Then it happens that the same solution, technical solution, is very useful for your friends working in the same field, and you just make them gift, you just present them because we're open, and then it grows up, and then someone comes with the idea, establishing just one small startup company, just making just this small kind of device as a byproduct of your lab. And then it just grows, and then as usual startups, it can be bought by some bigger companies. But I would say that there are many different histories of such companies. And there are many such companies, and some of them are really very interested in what we're doing, and they're coming to our labs, it's not just some kind of distribution of products that you don't need, like shampoos and so on, but really they just come to us, we explain what we do, how we use their last device, how we manage to improve it, or maybe break it, or explode it. And then they try to find a solution to repair it, to replace it. And then we explain what kind of next plans we have in our minds for the next 5-10 years. And then they start to think how to establish the new line of products which will meet our requirements in several years. And we just go in parallel. I guess in the Nobel Prize presentation of Serge Haroche, he also made this nice play-off between industry and science, and he showed that, for instance, the semiconductor devices, which was also the Nobel Prize back in the 50s, so now it's using computers that we use again to make our next generation experiments. And the same for the lasers. First lasers were developed just to control atoms, to control molecules. Nothing else. It's just to have special light that we just make with atoms what you want to do. And then now you have it in your CD, you have in your telecommunication, in the fiber, optical fiber. And again, we use it now just for the internet to control the experiment and to drive our research further. So it's really just come back and forth.
You mentioned that you were involved in the team that got awarded the Nobel Prize in Physics in 2012. Explain the feeling, how the team felt when you got notified about this.
Okay, good question. Feeling. So I was shocked. Okay, first of all, it was one day, and we knew that this is the day of Nobel Prize distribution, if you want, in physics. And since we have very many good friends which got Nobel Prize, it's always interesting to know who is the next, first in your field, and also to know what other fields of physics, because we're just focusing our atomic physics in quantum optics or quantum information, but physics is of course much wider. And of course it's interesting, you you get to know new people, new names, new fields, and this is the way how I learned about graphene and other things, which I found really exciting. And that day also we just came to the lab and we knew that, okay, there should be Nobel Prize announcement, and we just look online, and why not just making 5-minute breaks, drinking coffee in the morning, just in the lab, and you just switch this online. And then announcement started, and since they started to speak Swedish, for me it was not sure if they started announcement or not yet, because they were just talking Swedish, and then again Swedish. And okay, I didn't know if it's just if you should start to listen or not. And then suddenly I have heard the name that I knew, is Serge Haroche. I was a bit shocked, but I was sure that this is the kind of technical information, like member of some committee, just jury. And then continued speaking Swedish. And then the second name was David Vineland. And then I realized that this could not be just coincidence. And then, of course, 10 seconds, you hear nothing, you see nothing, you're just shocked. I don't remember that. I even don't remember what they were talking afterwards, because they started to show some slides and some photos. And I don't remember that. I just remember that 12 seconds after that, I just called my wife directly. It was my first call. And then I just ran out of the lab with my friends, and we just ran to the office of our colleagues, second part of our team, because we were looking for these announcements in different rooms. Yeah, okay, it was a bit of shock, and you don't believe it.
And some champagne.
Of course, we're in Paris. Just half an hour after, we just came to the nearest restaurant. We just bought the very large bottle of champagne, I guess 2 liters or 1.5. And just almost on the street, we just opened it. Unfortunately, Serge was not with us that day. He was shocked somewhere in Paris, because he got the call just while walking. And the second professor was giving lectures outside Paris that day. So we're limited, but it was a pity. But and then you just pick up your telephone phone and you just start call everyone in your phone list. I called my family here. I called my good friends, also physicists worldwide, just distributing this news. Okay, and then you calm down. Okay, and then you start to prepare for all this noise and all these events around this, because the first journalists, they just came to us after announcement. So at noon we were giving already first interviews in the lab.
But there was no pre-warning that you were nominated, that you knew that you were up on the short list for...
No, because first of all, you have to know this system, how it works. So the system is a bit complicated. So first of all, it's not just the pure decision of the Nobel Prize committee. So they don't make this short list. They don't make even the long list. So that what they do 1 year before each announcement, starting from just starting in September for the next year. So they start to distribute some kind of questionnaire to all Nobel Prize winners so far, to all big shots in different fields in sciences, just asking some proposal, whom you would like to see as the next nominee. So they do this, and they collect lots of information, of course. And then from this huge list, which is really huge, so no doubts, they try to sort out the more important, less important, and from now on, I don't know how it continues, because then it becomes really some kind of black box for us. And then the final or short list is ready somewhere in February. So from that time, you're not allowed to add someone into that list. Yeah, and then the next half a year, so up to September, they just really make this selection. How they do this? We should wait 50 years, I guess, because after 50 years, they open their archives. Yeah, so it's a bit complicated, and of course, you never know. You never know. And frankly speaking, I didn't expect it at all. Because when you work in something, you try to be really more or less more objective with respect to what you are doing. So you can be really excited by what your friend is doing, because you have no idea how it works, but it works and it's exciting. But as soon as you work on your own project, you see lots of small problems, technical details, cables which are burning, computers, lenses, cryogenics, and you're really in this mess, and you may be a bit underestimate your project. At least this is my feeling. So I don't know if it was the same for my colleagues, but I was trying to be really very, very objective, and it's better to underestimate yourself than to overestimate. But then when we got it, of course you start one day after, when you got up next morning, you start to analyze why Serge got it, and then of course you understand that yes, so it's not really surprising. You can nicely understand it. You can understand the level of this experiment and maybe somehow the arguments of the members of the Nobel Prize committee. I guess each Nobel Prize is really independent story, even between us and Dave Weiland. So even though we work in the same big field, the stories of two groups are pretty different, I would say. And also the level of impact also can be a bit different. And also decisions can be different. But this is another topic for conversation. So trying to understand why this guy got prize but not another one.
For people that are looking to make a career out, to get out in the world and further their knowledge and study abroad, and even though it might not be in the same field that you're working in, what would be your recommendations to people here in Ukraine?
So first of all, maybe first thing is to be a bit more frank with yourself. Really just to explain yourself what you're interested in general. Okay, so this is the first question after you finish in school. So maybe you will not give precise answer that I want to have this position in 12 years. No, but just in general, not to be afraid and just to tell yourself if you want to make physics, consulting, economy, or work on the plant or whatever. So I guess this is the first thing which is extremely difficult, especially because at that age you have influence from your parents, from your teachers, and maybe you don't have enough experience, and it's really difficult to find what you really would like to do. Of course, another thing, if it will be enough to leave from this job or not. And then, so you have to study. You have to study. You have to ask questions. You have to raise questions. You have to try to discuss as soon as possible everything that you find not very clear for yourself. Of course, you can spend some time trying to figure out yourself, but never put some unanswered questions aside. Try to answer every single question. If you fail, just ask your friends. If not, your teachers, professors, and so on. So this is important because, again, in my case, I remember that the overall feeling was that if you did not understand this lecture, it's basically your fault, but not the fault of the lecturer, and then just go back home and try to reread everything and re-understand. And it was not the best solution, because after 7 hours of lectures, you cannot spend 7 other hours to read and to think everything. But just asking questions during the lecture, it was not very normal, unfortunately. Now I try to say everywhere that. And then for the careers, when you get your degree, don't be too shy. So try to visit as much places as possible where you can work, or where you can study, or where you can continue your study, or where you can live, and so on. And I would say that there is never too many choices. There might be too few choices, but never too many choices. Especially if we're talking about some kind of career. Maybe another thing is that it's difficult to make a decision, but what we should also remember, at least this is what I tell myself and my kids, whatever choice you take, it will be the good choice. Because of course you never know what would be another choice, and what would be if I would go to another university, if I would do something else. So as soon as you take a choice, don't try to regret about it, but just continue, go on. Of course, at some time you might realize that this was really bad choice. If you have doubts, okay, just stop and switch as fast as you can. But when you start to walk, you just walk and walk. Don't try to turn your head. But this, it's very personal. there might be many other suggestions.
It's a difficult question to answer, I guess.
Yeah, because in my case, every time you change something, you change country, you change university, you change whatever, it's really difficult, and you never know if that was the most optimal choice, because you don't know. And that's why it makes no sense to think about if it was optimal or not optimal. But as soon as you took this choice, because you had your own arguments at that time, your own thinking, just try to take as much as you can with this choice. Of course, if you are sure that, okay, it was a mistake, just stop as fast as you can. Because life is too short to waste it to something not very interesting. Or in my case, it was like that. So the easiest solution was just to go to Bonn, because it was more or less natural. And then I started to look in which group to make my master thesis. Okay, to continue with PhD, it was natural, because I was so excited. I wanted to continue these experiments. Solution to go to Paris was extremely difficult. I have visited many other groups worldwide. I got some other propositions, because invitations. And for me it was difficult, because you have already family, you should change language, you never speak French, after living many years in one country in Europe while being Ukrainian, you go to a new country where you restart from zero. So it means in terms of language, in terms of all bureaucratic procedures, in terms of all rights, because if you want to get a long visa, you should stay some minimal number of years and so on. So to make this global reset, it was difficult, for instance. But from the other side, it was the opportunity to work in the group of Serge Haroche and to make this research. And that decision was very difficult.
And obviously the right one.
I don't know. We'll see.
So far, so good.
Hopefully it's not the end. We'll see. But final thought that I had before I really took it, it was whatever decision I take, so I would not regret, because I would not know what would happen in other cases. Because I saw that it's really, and let's just from this decision take as much positive as possible and just live with all possible problems. And so French is bad, but you can still learn it. You reset your years living in Europe, it's bad, but okay, I'm still young, so I'll do it. But if I'm in this group, okay, let's just do as much as we can do. And then, of course, after 5 years, you forget about all that doubts. For me, it's even funny to think about that, because, okay, it was natural decision, come on, and of course, no one regrets.
What are your professional aspirations for the future?
It's also a bit difficult to say. So far I continue to be, so I'm a permanent member of this small group, because group of Serge is really small. It's just 5 permanent members, so including me, myself, and about 12 or 10, 12 students, PhD students. So it's a really small group, and so far I'm still in this group, and I will continue to work here as far as it will make sense and as far as it will be interesting and useful for everyone. Because again, it's not just for me, it's also for the group, and we try to make this project, which is called this group of Serge Haroche, as successful as possible, as far as we can. And very probable that in some time, in 5-10 years, maybe some new ideas, some new physical system will pop up, and I will switch to another experiments. But so far, at least for the next 5 years, I'm pretty sure that we will continue, because we have, even after the Nobel Prize, we'll still have lots of other good ideas, what we can do, and we find them really exciting. What will be in 10 years, nobody knows, really. So maybe this is the nature of this scientific environment, where you have the permanent flow of people, you have people that change their topics, change countries, that restart from zero something after 20 years of research. And we have many, many such examples. Or you have physicists which work in the same lab for 50 years making good physics without going out. And nobody knows how it will be. So far, I hope I will continue to work here. And yeah, we'll see.
Do you think that there is a possibility that Ukraine establishes some interesting research in this field in the future? Maybe not directly in what you're doing, but in advanced physics?
Of course I would dream. I'm dreaming about that. So it it would be extremely nice if that would be possible. Of course, there are many problems, and now we're coming out of the scientific topic, but coming more to the economical, political, and other questions. And what I saw in Germany and in France is that you cannot have good science without open system, open social system, or open political system and economical. So you cannot force someone to make science. You cannot force someone to solve this equation, but not in this one or that one. So you cannot control science. And unfortunately, if you are limited in financial resources, in money, you have to control science. If you have just $10, you have to think whom you will give them and how to be sure that they will be spent in a good way. And since normally this is the government that give money, so if they try to control us, so nothing good happens. And this is the case in Ukraine. So you have limited financial support, and you're not allowed to give freedom to scientists because you're not allowed that this money will be wasted. And of course, we should understand that science, it's the risky enterprise. So maybe one group out of 10 groups will get some interesting results. And maybe only one group out of 10 groups with interesting results will get some result which will be also useful. So it's a kind of startup. So if you just make comparison, and you have to give freedom to scientists. And again, we have lots of examples in history when people were concentrating on one questions, and then they just changed their mind and then just went out, and then they forgot about their main aim, and then they find out many other extremely nice and important phenomena, and this would not be possible under this control. So in Ukraine, you have money issue. Another thing is, of course, corruption. So you should be sure that this money will be spent in the proper way. You should be sure that having $10, I will buy equipment for $10, but not for $1, because $9 are spent, Again, I'm not, so fortunately in France, or in Europe, it's a bit more transparent. Another thing is, of course, financial support of personal researchers. You cannot motivate young people to go into the science if the scholarship of the PhD student is about $10 or $100 or $150. I don't remember exactly, but it's really something ridiculous. And now, after getting your master degree, you have a choice. Either you go to some company as the technical staff, or you continue with PhD, which will take another 3-4 years, living on this ridiculous money.
Is there someone that you would recommend for us to interview?
Oh, yeah, sure. So in my field of quantum optics, we still have some people working on these aspects to some extent, and one of such physicists is Professor Dotsenko, Leonid Petrovich. He is the director of the Institute of Physics of the National Academy of Science, and at some point he even helped us with some theoretical calculations and analysis. He spent pretty much time in Europe working in collaboration with different European and American groups. So he's familiar with the European and US system, and being the director of this institute in Kiev, he might, of course, he has better overview of all problems that our national science faces these days.
If you could give me an introduction, I would be very happy to interview him.
Yeah, sure.
Something that you would want to recommend?
There are many interesting things to do and to try, and they're different. And of course, there are some natural, obvious things like hiking, diving, rafting. So it's no question you should try to do this. Another thing, so I have kids, and maybe I should recommend that you should not wait too much before starting to get kids. So you should do it as fast as you can, because it's extremely interesting and it's fantastic. Of course, it limits your life when you have children, but on the other side, it really it opens you a completely new world in life that you cannot see and you cannot even imagine without kids. Of course, we have career and we talk about this and question of time and so on and so forth. But in my case, so my first daughter was born when I was still a student. Even not a PhD student. I was a student in Bonn, in Germany, and I'm very happy of that, and I became very, very happy and It's lucky. Okay, so kids. So it's a new field of inspiration, and also for the science, because if my daughter cannot understand what I'm doing, I should find better words for the journalists to explain this stuff. So I tried all this with my daughter, first of all. If she starts to imagine or draw something or re-explain in some simple words, I understand that, okay, my explanation was more or less clear. So I can go out to the broad audience.
And how old is she?
So my older daughter is 11 years old, and yeah, she likes very much science, and she likes museums of science and technology, and she likes to make some experiments at home, and of course for me it's kind of relaxation. After doing some big physics and big experiments, you come back home, and I try to make some small, very naive, very simple experiments with your kid, which are really extremely fascinating. You cannot imagine it.
If you have something that you think with some degree of certainty will happen in the next, say, 5-7 years?
I don't know. First of all, because I'm a bit aside from the modern technologies that we use in the everyday life. So I'm more focused on the technologies that we need for our experiments and for our research. Of course, no doubt that we will go more and more to the green energy, non-carbon sources of energy, and this is extremely natural. Nowadays, if you think that for every airplane you need tons of fuel, and there is no solution how we can replace this fuel by something else, even with batteries, so far it's extremely difficult. So in a sense, it will be really an important question. So in terms of the science, I think that this century, so the last century, definitely it was century of the quantum physics, because it really stimulated lots of other fields. It stimulated technology, superconducting technologies, computers, communication, chemistry, quantum chemistry, biology, control of everything that we see around us. I would say the 21st century, I guess it will be more the century of the biology. So we're going deeper and deeper into the cells, and I'm really excited to see what will be found out in 5-10 years, especially in the respect of the problems of cancer and other diseases. Because again, you see all these advances that they're doing, and so they're extremely good in that. In some cases I feel shame for what I'm doing, because I think, okay, maybe it's not so important for the mankind. Maybe it would be better to spend time on the energy issues, on the cancer issues and others. But then, okay, maybe my choice was too good.
Igor, thank you very much for coming here. It's been a true pleasure to talk to you and hear your insights about your work, and congratulations once again on the
Yeah,
prize.
thank you very much, and you're welcome, and thank you for inviting me.
So that was our interview with Igor Dotsenko, a very bright and gentle man. If you wish to get in contact with Igor, you can contact us through our webpage, socialite.nu. If you do have someone that you want us to interview in the show, please let us know. We've got quite a few good suggestions in already, but I'm sure there is much more out there. Thank you very much for listening, and hope to see you soon. Take care.